Hey, soldier, welcome to Pocket Ronnie. Sit down, pay attention, and conquer your fear of math.
Okay, now we're going to be doing ratios with chemistry. This is different than what we did in lesson 14 with the percentages of chemistry, because now the problem is asking us for the mass, okay? Right here, we are given a total mass of a compound, okay? And what we did in lesson 14 was find out the atomic weight of each element. We still have to do the same thing here, but we are finding the mass of each element, not the percentage of each element. So it's two very different, they're different. They're not very different, but one you're finding the mass, the other problems we were finding the percentage, okay? We still use the same information, so we still need to go to the atomic weight table and find out that. We go look it up, and remember, the numbers that I am using are rounded numbers, okay? I'm using rounded numbers, not the exact decimals from the atomic weight table. So carbon, there's only one atom of carbon, so therefore that's 12. Remember, this is the atomic weight. Weight is very different than mass, okay? So this is the atomic weight. We will be finding the mass. Okay, our next element we had was 2 atoms of fluorine. So, and if you look at the atomic weight table, fluorine is 19. Multiply that by 2, and that would be 38. And then we have chlorine, and we have 2 atoms of that. So if you look at the atomic weight table, chlorine is 35 times 2 atoms, and that would be 70. So we're going to add up each of these weights, and that would be a total of 120. Okay? So we're going to use this information that I just did over here. We're going to use this information to make ratios to solve for the mass. We're going to use this information as well as the total mass to make a ratio. Here are the ratios that we're going to make. We're going to make a ratio of the part over the total, and we did this in lesson 14, but to find a percentage. We're going to set it equal to another ratio of part over the total. This ratio, we're going to use the atomic weight. This ratio is going to come from the mass. Remember, weight and mass are two very different things, okay? So for this ratio, we're going to go to the atomic weight information to make this ratio. We're going to do the part over the total. So we're looking at carbon, so the carbon is just 12. So we have 12 over the total. The total weight of the compound was 120. We're going to set it equal to another fraction that has to deal with the mass. We don't know the part is carbon. If this is carbon in the numerator, carbon has to be in the numerator on the other side of the equal sign. We don't know the mass of the carbon. That's what we're looking for, so I'm just going to put a C. Over the total mass of the compound, we were told up here in the problem, we were given that it was 480 grams. Okay, now we have a fraction set equal to a fraction, so we can cross multiply to solve it. Okay, using cross multiplication, we can do 12 times 480 grams on one side of the equal sign, and then 120 times C on the other side of the equal sign. Okay, so 12 times 480 is 5,760 grams equals 120 C. Divide both sides by 120, and comes out that the amount of carbon is 48 grams. So we found the amount of carbon, not the percentage of carbon, as we did in lesson 14. Now look at number 7. They're asking us for the mass of fluorine. We do the same thing, okay? We are going to set a ratio equal to a ratio, and we're going to say the part over the total equals the part over the total, except this ratio is going to come from the atomic weight. This ratio is going to come from information from the mass. So looking at the atomic weight of fluorine, just fluorine alone was 38. Okay, so 38 goes in our numerator, and then our total will go on the denominator. The total atomic weight for the compound was 120. Okay, now we're going to make a ratio that's the mass information. Okay, the mass of the fluorine, we don't know, so I'm just going to put an F. And then the total mass of the compound goes in the denominator. That was 480 grams. We were given that. You can see how our totals are always going to be the same each time. The total atomic weight will always be 120. The total mass of the compound will always be 480 grams. Okay? It's just our numerators that are changing each time. So now we can cross multiply. So when we cross multiply, we have 38 times 480 grams equals 120 F. So 38 times 480 is 8,240. And we divide both sides by 120. That's grams. So the amount of fluorine is 152 grams. And I should really have a subscript of 2 on each one of those, because that's how many fluorines we have in our compound. So I should have a subscript of 2 on each one of those. So, okay, now they want to know the mass of the chlorine. Okay, so we're looking for the mass of our chlorine. Same thing, we're going to set a ratio of the part over the total to a ratio of the part over the total, except this first ratio will make it the atomic weight information, and the second ratio will make it the mass information. Okay, so for the atomic weight, chlorine alone, that was 70 over the total atomic weight, which is 120, and then mass of the chlorine, we don't know that, so we're going to leave it as that. And then the total mass of the compound was the 480 grams. Okay, now we can cross multiply to solve. So we have 70 times 480 grams on one side of the equal sign, and then 120 chlorine on the other side. So 70 times 480, 33,600. We're going to divide both sides by 120. So that means that the amount of chlorine we have is 280 grams. Again, don't mistake this for finding the percentage. We just found the amount of each of our elements, not the percentage. Alright, we're looking at 16D, 4 through 6. We're doing another chemistry problem of ratios. We have 752 grams of K2O, potassium and oxygen. Okay, so I'm going to go to my atomic weight table so I can get how much each one of these weigh. So for the potassium, it's 39 times 2, because there's 2 of them. That subscript tells you 2. So that's going to be 78. And then the oxygen, there's only 1 of them, and oxygen is 16. So add those together for your total, and that would be 94. Okay. Now number 4, it says list all possible equations or ratios. I like the word or ratios. So remember, we can always do part over the total. So if we did part over the total, we'd be doing K2 over the total. And with that, we would have 78 over 94. We can also list the oxygen over the total, and that would be 16 over the 94. But we can also do what we haven't done so far. You can do the part over the part. So we can actually make a ratio of K2 over the oxygen. So that would be 78 over 16, or you can reverse these numbers. When you're doing the part over the part, it doesn't really matter which one's in the numerator. So this one is not used as much. I mean, it can be. You just need to know that you can do this. You can make a ratio of one element to the other element. So, okay. So looking at number 5, we want the mass of the potassium. Okay. So again, we're going to set up a ratio of part over the total to part over the total. The parts always has to stay, if part's in the numerator here, it needs to stay in the numerator there. This one's going to be the atomic weight information. This one is going to be the mass information. Okay? So to do the potassium, we're going to do the K2 over the total to K2 over the total. So let's get the information from the atomic weight. So for potassium is 78 over the total atomic weight, which is 94. This is our atomic weight ratio. Now let's do our mass ratio. We don't know the mass of the potassium, that's what we're trying to find, but we do know the total mass of the compound is 752 grams. Okay? We can now solve this by cross multiplication. When you have a fraction set equal to a fraction, you can cross multiply. So 78 times 752 grams equals 94 times K2. Divide both sides by 94 to find out that the amount of potassium is 624 grams. Okay, now let's look at the mass of the oxygen. The same thing, we're going to do the part over the total. We're going to do the atomic weight information, the part over the total, which is the oxygen over the total. We're going to set it equal to the mass ratio, which is the oxygen over the total. Keep everything, oxygen's in the numerator here, it's in the numerator here. Total's in the denominator here, total needs to be in the denominator here. Okay, so for the atomic weight information, our atomic weight of oxygen is 16, and then the total atomic weight of the whole compound was 94. Now let's go to the mass information. I don't know the mass of oxygen, that's what I'm trying to find. That's my unknown. The total mass of the compound is 752 grams. We can use cross multiplication to solve this. Cross multiplication means 16 times 752 grams on one side of the equal sign, 94 times oxygen, and that almost looks like a 0. I probably would do that for it to be a 0. So since it doesn't have a line through it, it's oxygen. So we divide both sides by 94 to find out that oxygen is 128 grams. Okay, the one thing that I want to point out is if our total mass is 752 grams, these two things should equal 752 grams. And they do. 624 plus 128 is 752 grams. Yes, we probably could have took this and subtracted it from 752 to find out this, but I think it's good for you to still go through this work to figure out this mass. So at the end, it's a check. Do your two masses equal the total mass?